Good afternoon and welcome to this webinar hosted by Element 14 and Texas Instruments. Today we're going to be discussing add lithium battery charging and management to your designs with the Fuel Tank BoosterPack from TI and Element 14. We're fortunate to have with us from Texas Instruments, Kaita Johnson, Miguel Aguirre, and Ming Yu. And from Element 14 we have Vandana Lokeshwar. If you have any questions for the team during the course of the webinar, please feel free to put it into the chat or the Q&A windows, and I'll ask it at the end. And for now, I hand you over to the capable hands of Vandana Lokeshwar. Take it away.
Thanks, Christian. I'm going to let Kaita first talk a little bit about why battery management, and then we'll go on to discussing a little bit on the Fuel Tank BoosterPack. Kaita?
All right. Thank you, Christian. Thank you, Vandana. Hello, everyone. So on behalf of Texas Instruments, I'd just like to say thank you to all of the webinar attendees for coming today. Today we want to ensure that you take away the benefits of using our Fuel Tank BoosterPack, how it works at a high level, as well as how TI battery management can help you with your next design. Before we get into that, though, let's chat a little regarding battery management in general. Why is it so important? How is accurate gauging, cooler and faster charging and protection vital for your product designs? Well, the first thing is fast and safe charging. Your customers don't want to have to charge your devices for hours at a time for a full charge, but you also have to ensure that the rate of charging is safe for the user and for the battery. Using the battery protection and charging techniques that optimize the speed of charge while protecting the battery are essential so your device runs without battery issues. The second concept is maximize the battery life. When your customer unplugs your device, they want to get as much battery life as they can out of that charge. As the designer, you want to ensure that your gauging is as accurate as possible so your customer can maximize the time they spend on your device at each charge. If you have 1% error versus 30% error on your gauging, you do not have to protect against the potential loss of data for longer, which results in longer battery life. Getting those extra minutes or hours due to the accuracy of the gauge you put in your device could make the difference on an electronics review site like CNET or Wired. The third idea we want to discuss is talking about making your battery smarter. You know that feeling you get when your phone is at 2% and you're not sure if it'll power off during your phone call or during this webinar? Or when you're navigating somewhere and you hope that you can get there before your phone dies? At TI, we call that dead battery anxiety. And with a smarter battery, we can work to eliminate these issues. Optimize how much power your application uses and get accurate readings on the battery's state of charge with battery management. Lastly, with the Internet of Things movement going on and a general push towards wireless, battery management is an essential piece of advance in this type of technologies. Wireless charging will take your everyday experience to the next level. We can eliminate battery anxiety by recharging your device when it's at your desk or in your car's cup holder. Having your device charged via RF waves, this is what's next, and battery management will help make that a reality. So with that, I'd like to pass the mic along to Vandana, who will go into more detail regarding the Fuel Tank BoosterPack and how it can help you add these benefits to your designs.
Thank you, Kaita. Good morning, good afternoon, everyone. My name is Vandana Lokeshwar, and I'm from Element 14. I'd like to really go through and introduce a new member of the Texas Instruments LaunchPad and BoosterPack ecosystem, our Fuel Tank BoosterPack, which we've basically designed and developed and manufactured in collaboration with Texas Instruments. So the Fuel Tank BoosterPack is essentially has been designed to provide battery power to the LaunchPad development kits from TI. On board, like you can see in this picture, there is a lithium polymer battery charger, a gas gauge, high-efficiency buck boost converters, and basically indicator LEDs for charge indication as well as low battery. I'll go into some more details in the next couple of slides. The booster pack comes with a 3.7-volt, 1,200 milliamp hour lithium polymer battery, and it can be connected to the launch pads via the two 20-pin headers that you see on either sides of this PCB here. And this is compatible with all the launch pads, whether it's the MSP430, the TVC, or the C2000. So it is compatible, and it can be, all the software and solution is provided so that you can read out the battery state outputs with temperature, voltage, average current, and so on from this booster pack. So it's really, essentially, it's been designed to provide that flexibility and portability and mobility, right? So in this day and age, it's important with technology, Internet of Things getting so popular and widely used, it's important to have that flexibility that you can actually stand independent of power and actually powering through a cord that is plugged into a mains output. So let's get into a little more details on what the actual, battery charger and gas gauge does on this board. So we are using the BQ24210, which is a really highly integrated lithium-ion linear charger. And it comes in, most of these ICs that we have picked, they come in really small packages, so they can be used for, those space-limited kind of applications, and ideally for portable applications. So this has a single power output, the BQ24210, and basically the battery charging goes in 3 phases. So firstly, conditioning, then it's got the constant current mode and the constant voltage mode. What happens in all these charge phases is there is an internal current control loop that monitors the junction temperature of the IC and reduces the charge current if there is an internal, if the internal temperature threshold has been exceeded. It comes with the high input voltage range and overvoltage protection on the inputs as well. And what it enables is the use of low-cost, unregulated adapters. So you could even plug in like a power source, say, from a solar panel or an inductive charging pad as a power source to this. The second key IC on this board is the BQ27510, which is the gas gauge. This is basically a single-cell lithium-ion battery pack fuel gauge, and comes integrated with a 2.5-volt LDO. And all the sensing happens through an external, about 10 milliohm sense resistor. So it monitors all the current, and internally it has TI's patented impedance track technology. And what happens with that is it uses an algorithm internally which measures the cell details, characteristics, and the properties, and it creates a state of charge prediction and can achieve really about less than 1% error across a wide variety of operating conditions and over the lifetime of the battery. Because as the battery is being used, even if the battery, because of the battery aging and the chemical technology that is used within it, it automatically adjusts for those kind of parameters for the battery aging, self-discharge, temperature, and rate changes as well. So one of the things it also supports is a I2C serial interface to a microcontroller, and with it you can read out reports regarding, say, remaining battery capacity, which is typically reported in milliamp hour, a state of charge in percentage, a run time to empty, so when is it actually going to be completely discharged, in minutes. The battery voltage can be read out in millivolts, and the temperature also in degrees Celsius. So, and we'll talk about, how our software that we provide together with this kit actually reports back these details that we've just mentioned. The BQ27510 also comes with an internal non-volatile memory of about 32 bytes, and this is really to store all the cell information on basis of which the algorithm works. Also on board are 2 high-efficiency DC-DC converters. Like as indicated here, it's up to about 96% efficiency. It comes integrated with a 1.8 amp switch and has a wide input voltage range of about 1.8 to 5.5 volts. So we have 2 of them, one for the 3.3 volt and one for a 5 volt. So power is supplied to the LaunchPads, like we mentioned, via these 2 BoosterPack connectors, or LaunchPad connectors. And the 3.3 volts and 5 volts is fed into these connectors. So you could basically plug in your LaunchPads, source the power from this battery BoosterPack, plug in the battery, and power your LaunchPads. And even you could actually build your ecosystem of different BoosterPacks onto this, like use of sensor booster packs, wireless booster packs, and so on. I'll give you a few examples in a couple of slides. So as mentioned before, we do have complete software support for the booster pack together with support for the TVC LaunchPad, the MSP430, and the C2000. And what it does is you would have to install the Code Composer Studio. So we've got examples, project examples with version 5.4, and it can be used for 5.4 or later. So what happens is once the software is installed, a USB serial COM port driver is also installed which helps you communicate with the PC with the LaunchPad hardware. And once you open a terminal with the preset conditions of the baud rate, you're able to read out with all the different parameters of the battery as indicated in this. So you can read out the temperature, the voltage, and the current, and so on. So it's all these project files for each of the LaunchPads are provided on Element 14, as well as they're available on TI's eStore with all the detailed documentation in the user manual. So in addition to the support that is provided with Code Composer, I'd like to talk a little bit of the Energia library that has been created to support this Fuel Tank BoosterPack. A little bit about Energia. So it's basically an open source prototyping platform and based on the wiring and Arduino framework. So it's built by a community and includes this IDE that you see on the side. And it really allows all users to get started easily. It's a collection of user code. People contribute their own codes based on different LaunchPads and BoosterPacks onto this community, and you're able to port the code really easily across the whole LaunchPad ecosystem. So you see this list of boards supported or LaunchPad supported within Energia, right from the MSP430 to the TVC, the older version for the Stellaris LaunchPad as well. Energia, the other great thing about it is it supports both Mac, Linux, and Windows OS. So the code is provided a link here where you can download the actual code. And what this also does is once you install the Energia IDE onto your PC for the respective LaunchPad version that you have, you download this code from here, unzip the files, unzip this library into your Energia install, and straight away run the example. Now, so this example here has been created based on TVC, but it's really, really easy to port it over to the other. You could do the same thing with changing your target to either the MSP430 or the C2000 LaunchPads. And it helps you get started, in a couple of minutes, literally, if you are using any other target hardware. So same thing even here. The software allows you to read out the battery temperature, the charge, the state of charge, and the different parameters that we mentioned before. Another thing I'd like to mention here is the Energia library actually even works with other BQ devices as well. And this is thanks to the contribution of Ray Villo from the Energia community for this library. So it's very interesting. There are a lot of more examples that you can use Energia for, whether with the other booster packs and LaunchPads together with the Fuel Tank. So I encourage you to visit this URL here, energia.nu, for more details, again, on the actual software, the IDE, and how would you use it for your applications. So now to talk a little bit about Texas Instruments LaunchPad and BoosterPack ecosystem. So really what this ecosystem consists of is all the components, all the different hardware, software, and solution documentation that you would need to for developers to really create differentiated projects and solutions. So the LaunchPads basically, so the ecosystem consists of LaunchPads and BoosterPacks from a hardware standpoint. And what a LaunchPad is really is a microcontroller-based development kit from TI. And BoosterPacks are the plug-in modules that fit on top of the LaunchPad. And TI has now standardized all these connectors so that even third parties can develop different BoosterPacks for different application-specific requirements, whether it's a wireless or a sensing kind of thing. Even third parties can develop because now this interface has been standardized. And as long as you support that interface on the board, it should be able to plug into any of the base LaunchPads. So So here are a couple of examples that typically how you could use our Fuel Tank BoosterPack in different applications. So here, like we have a battery-powered NFC or RFID tag reader. The TRF7970A has basically got an integrated analog front end and the data framing device for a 13.56 megahertz RFID NFC communication system. So together with a 5529, MSP430 5529 LaunchPad and the battery booster pack, now you have a standalone battery-powered RFID tag reader. Another example of an application of the Fuel Tank BoosterPack, and to kind of showcase its flexibility and portability, is creating a multi-point sub-gigahertz RF temperature sense node. So you have the CC110L, which comes with a radio module and an integrated antenna on it. It basically supports the ISM band for Europe, the 868 megahertz, and US, the 900 megahertz frequencies. The software stack, so there's a software stack also included with this, and together with this temperature sense booster pack from TI, which uses a TI device, the TMP006, you can actually create a low-power temperature sensor application, and also it supports the star network topology with one hub node or even up to, I think, about 4 sensor nodes it totally supports. So now adding our Fuel Tank booster pack to this, you've again created a wireless sensor node without the need of actually, powering it up with a mains-powered system. And the other, another example I'd like to, showcase here is this the PCHID application or an air mouse based on the T-with-C LaunchPad. Added to it is a sensor hub booster pack, and the sensor hub basically consists of sensors for pressure, temperature, accelerometer, gyroscope, and then add these two kits here are 802.15.4 or Zigbee transceiver kits. So now, again, you can provide a complete, wireless mouse kind of experience with all the sensors that you have here. It can detect the motion. And together with our battery booster pack, again, it gives you that flexibility and mobility to actually stand independent of a mains-powered kind of application. So these were just a couple of different, what we call quick demo recipes that you can use and leverage the entire ecosystem of booster packs and you're able to stack one on top of the other, multiple booster packs on a LaunchPad. With the connectors that are made available. And you can create your own applications. You can create your own booster packs. And this really, allows you to expand that complete ecosystem as well. So with this, I'd like to hand it back over to Kaida to walk through a little more about TI's battery management portfolio and a kind of deep dive into the different devices and its features.
All right, thank you, Vandana. So looking back at what I had said about battery management, fast and safe charging, maximizing battery life, making your battery smarter, and cutting the cord, all of these ideas and concepts are huge priorities behind TI's battery management and this booster pack. And here's how we make that a reality. Using TI battery management enables development of the latest technologies. Things like impedance tracking, a TI proprietary algorithm which gives much higher accuracy than Coulomb counting or other algorithms. We are able to give up to 99% accuracy and greater than 90% efficiency with less battery degradation with this and our faster, cooler charging technologies as well. Secondly, we have a comprehensive battery management portfolio. We have parts that range from gauges, chargers, authentication, protection ICs, integrated parts, and more. These are high-performance products that are backed by the experience and expertise of over 200 engineers. Thirdly, and something that I will focus on a little bit more in these future slides, is getting you and your product faster to market and faster to production. Development times are shortened with TI battery management because of the wealth of resources we have available to you. Things like app notes, our engineer-to-engineer forums where you can interact with our senior engineers within our businesses, Power Lab, WebBench, where you can come up with a power design in minutes, evaluation modules for each and every part, and of course our Fuel Tank Booster Pack, for example. I'll hit the next slide here. So just going a little bit more in depth with the faster time to production, we have resources, for example, called TI Designs, a collection of example designs that can help you reach production faster because they already have the block diagram set up, the technical resources needed to test the designs, and these have already been proven designs that work. Using these as a base point reduces the amount of man-hours drastically to create a new design. With 73 applications for these system block diagrams, from solar applications, e-meters, e-bikes, there are a wide variety of applications where we can help add value for your designs. In addition, a great resource on ti.com/battery is Battery Management University. It is a collection of videos that discusses great topics like choose the right charger and wireless power design, things that can help with your battery management design and help you understand the TI battery management portfolio and how it can help you. Lastly, utilizing this booster pack and things like Gauge Studio, an exciting new development to accelerate the gauging decisions on your designs, is going to help accelerate your design and help you get quicker to market with the latest technologies. Here is a high-level display of the products that TI Battery Management makes. From chargers, gauges, cell monitors, protection, and authentication, this truly shows how our portfolio can help you with your entire battery management design. Taking a look at the technologies in more detail shows the impact it can have on your next design. Talking about up to 99% accuracy with our impedance tracking algorithms, which extends your runtime and lifetime. Talking about wireless power with our charging portfolio and energy harvesting. Talking about authentication with our performance and safety benefits. In addition, I'd like to talk to you about where battery management can make an impact. As you can see from this slide, battery management is in a position to make a major impact in a variety of applications in many industries, including consumer, industrial, automotive, medical, and more. Even at CES, many of our products, including our gauges and chargers, were in products like the Bramo bike, an e-motorcycle, a variety of wearables, Bluetooth speakers, and more. With that, I'd like to bring Miguel in to discuss the TI battery charging portfolio and why it can have a substantial impact on your next design.
Thank you, Keita. Hi, everyone. Hope you guys are having a great day today. So TI charging, there's a couple of things that we focus when we develop our TI chargers. One of them being accuracy. We are looking at 1% or actually better in some of our newer battery chargers. The whole purpose of being able is to allow you to more aggressively charge your battery to have a little bit more energy stored into it and essentially extend your runtime from your battery. Efficiency, as most of this, a lot of products go into either higher capacity batteries and even smaller or thinner product design. Efficiency becomes a big problem in a sense of heat. A lot of the times, the system designer will try to maximize runtime on the battery, which means you go to a large battery, but then when you try to charge that battery fast, you have a thermal budget that you need to hit. So with some of our newer devices, such as the BQ24-190, we're actually able to hit 90+% efficiency at charge currents in 3 amps and 4 amps and above. In addition, then we have a lot of different features to try to make the systems design a little bit simpler, a little bit smarter, a little bit smaller. We have a wide selection of battery chargers, anywhere, as Keita was mentioning, linear, switch mode, wireless power, notebook chargers, you name it. Looking at lithium iron phosphate, nickel metal hydride, any type of chemistry. We have our very small solution size, like the BQ24040, which is a 2x2 millimeter charger with 30-volt protection and charging up to 1 amp. And then we also go into the high-efficiency switching chargers, such as the BQ24250, which is a 2-amp charger, 24260, a 3-amp charger, and 24190, a 4.5-amp charger. And some of these chargers also we include features such as USB on the go, so that with the use of a single inductor, you can actually charge the battery or provide boost back to the input, therefore reducing your solution size. In addition to the single-cell chargers, then we also have multi-cell industrial type of chargers, such as the BQ24170, which is an integrated FET 4-amp charger that runs for very high efficiency. And then for even higher currents, 6 amps, 7 amps, we have controllers such as the BQ246XX series, which are charge controllers, all the smarts integrated into the IC, and then you size your application with external FET for the amount of power that you want to deliver. We also have advanced notebook chargers, such as the BQ247XX series, including features such as the Turbo Boost for Intel designs. And then on top of that, we have many other features, power pads to allow you to power up your system, even under a dead battery condition, so that you don't have that feeling of you connect your product and it takes 20 minutes or 30 minutes for your product to power up. JADA, which is standard from Japan, specifically targeting charge profile versus temperature of the battery, and then thermal regulation to maintain your system design at a cool or controlled temperature level, and many others. Going to the next slide, now we want to talk a little bit about specifically the charger being used on this booster pack, the BQ24-10. This is actually a linear charger that can be used and was designed actually to work with solar panels. So you can connect the USB source and charge your battery, or in addition to that, you can actually connect a solar panel. And with that, we have a VIN-DPM feature, which you can program with resistor dividers. And what you can do is try to extract as much current as possible from your design. In addition to that, you can also, if your environment is pretty controlled, you can actually characterize your solar panel and try to create an MPPT system. In other words, a maximum power point tracking by using this VIN-DPM feature. In addition to that, we have limited power charging mode, which means when you have a limited power source, we can charge at a reduced rate without tripping termination too early. And with most of our chargers, we look at very robust protection from the input. In this particular case, we have a 20-volt charger that can operate from sources all the way to about 7.5 volts as well. Next slide, please. And this is a snapshot of just showing the different type of chargers that we have in BMS or battery management systems. This particular case, I'm showing single-cell batteries or single-cell battery chargers. So we have anywhere from charger protection front end. So these are protection devices to protect downstream systems from faults occurring on the outside adapters. We have harvesting applications, the BQ25 series, which can operate from single-cell solar panels and then charge either a supercap or even a battery or thin film battery type of element. And this is looking at very low powers. In this case, we're talking devices that can operate from 300 millivolts or 200 millivolts on the input, boost type of converters. And on top of that, we also have the TPS627-3X series, which are ultra-low power buck converters. This particular device, we're actually able to achieve 90% efficiency at load currents of 15 microamps, which translates to approximately 300 nanoamps of quiescent current when there's no load. So pretty impressive performance there. And then if you look at what we call the wire charging portion, we have linear chargers and we have switch mode chargers and different kind of features, single input, multiple inputs, power path, meaning that you have a battery output and you have a system output, and this allows you to do power up even under dead battery conditions quickly. And some of the products that we recently have released, the 2425X on the switch mode side, 2426X on the 30-volt 3-amp side, and then 2419X. And last but not least, wireless charging. There's a lot of interest out there for wireless charging. TI has actually released 2 versions of wireless chargers, both WPC 1.1 compliant, the BQ5101X and the 5105X are currently released, and with other parts coming. And now I would like to turn it over to Min, who's going to talk a little bit about TI gauging.
Thanks, Miguel. So I hope everyone enjoyed the presentation so far. When you talk about the, battery gas gauge or gauging algorithm, traditional way, usually we use a voltage-based or coulomb counting-based, but with the different end applications and different load conditions, more and more customers found out that the traditional way to measure the battery capacity with the reported SOC is no longer enough. So they're looking into how can we use a gas gauge to precisely predict the remaining capacity, as well as how can we use the gauge to predict how long this battery will last. So state of charge as well as state of health become the standards requirements at minimum for gauging. So in TI, we have a advanced technology. The reason most customers see a big arrow when they report battery at different environment conditions because the impedance inside the battery is changing with the temperature, with your load, with the age of your battery, and causing a lot error when they use in traditional way to measure the battery capacity. But with the impedance tracking algorithm, which is patented technology developed by Texas Instruments, we can actively learn the impedance inside the battery while this battery is still being used and deployed in the field. And that algorithm is automatically running inside the gauge. So to the system design, the gauge is a very independent device that not required host to develop any kind of algorithm. All the system do is to read all the information from the gas gauge, and then a gas gauge will report based on the different environment conditions. So the accuracy with the impedance track algorithm is very good. It can up to 99% accuracy. So with that, let's go down to the gauge we used in the booster. This gauge is 27510-G3. That is our mature device. It's a QFN package, which is a very low cost in terms of PCB building cost. This is our high-end host side gauge. That means this field gauge will be put on system board, and with the proper chemistry as well as configuration, this gauge can go up to 99% accuracy. The turnkey solution, when we talk about turnkey solution, that means once you have the chemistry, everything configured properly, all your system need to do is to read from the I2C communication line to read out all the parameters such as the state of charge, remaining capacity, time to full, time to empty. We have a lot of information that's being calculated and stored in the gauge register that allow host to read. We also have some type of interruption that can have a hardware interrupted to the host side if the battery is low or there's some other issues triggering certain type of interruption condition. So that way, your host, you don't have to always pull into the gauge to read. You can set a certain threshold, then at a certain threshold, the interrupter will trigger out to the host side, then you can wake up from the host and read back from the gauge. So this is like a more advanced gas gauge used in the host side. If you go to the next slide, you can see our, next slide please, yes. You can see we have a broad spectrum of all kind of different gas gauge. This picture is a little bit overwhelming if you look at first, but let me explain what is each section. If you look at the column from left to right, so the far left is our battery management unit. We call it battery management unit. That means this is not just a gauging. It is a gauge, but also it controls the charger. The reason we have this control is because the max life algorithm that we developed 2 years ago can help the charger to charge the battery in a way that can maximize the battery life. So we call it max life. The way it controls the charger is through the I2C. So if you look at the two devices on the top, those are system side BMU. The 27530 is compatible with our charger 24106X, and the 27531 is compatible with our charger 2419X. So the autonomous control of the charger is all done by gauge itself. That means on the host side, you really don't need to have a separate set of algorithm control the charger. It's all done by the gauge. Although this is a two-chip solution, we have some customer already implemented this, and they demonstrated the extra battery life that they can get out of this solution. On the bottom, that is a pack side BMU. So this is the same principle, but this device, 40Z60, is in the battery pack. So the host side gauge and the pack side gauge, in principle, they all have the similar algorithm, but they may have different hardware in I/O because the location difference. So that's the high-end BMU, which is charger control, gauge control charger. If you look at the second column from the left, that is our high-performance gauge and protectors. So high-performance gauge, as we know, 27510, that is already used in the BoosterPack. That is a QFN package. But we also have a CSP smaller package called the 27520, also used on the host side. So this tool is the most popular host side high-end gauge. If you look at the bottom box, that's a pack side high-performance gauge. We have 541, which is a QFN package, as well as 545 CSP version of 541. Then we have 27741, which we integrated a protector in the field gauge. So this pack side gauge will allow customer to connect the battery cell with the gauge during the pack making process. So once this is put into the battery pack, it will never take out. The gauge will stay with the same cell. So in terms of accuracy, I would say the pack side gauge can give you the highest accuracy that you can get. 28Z610 is also another gauge on the pack side with integrated protection. It's a QFN package. So those are the family for the pack side high-end. If you look at the third column from the left, we also have a gauge that can be used easily for different kind of applications. Mainly, those customers, they don't require a very high accuracy, but they do require less time to develop the gauge. So they want the development cycle as short as possible without going to a detailed configuration, detailed chemistry, profile setting. So what they want is kind of like plug-and-play type of a field gauge with okay parameter setting with reasonable gauging accuracy. So the design target for this 421, 441, 621 is 5% error. So that means with the selected cell, for example, 4.2 volt cell or 4.35 volt cell, all you need is select the right parts and then put into your system, update maybe 3 to 4 parameters, that's it, and you can get up to 5% of error. So that is the key point for those type of gauge. I would point out that 421 has an integrated sense resistor. That means you don't have to add an external sense resistor, which save you BOM cost. 441 is target for the high current application. It is a QFN package, but also they have an external sense resistor that can handle all the way up to 8 to 10 amps of current. And 621 actually is our advanced algorithm. It's called impedance track ITDVC, which means it's a IT, it's an impedance track, and also it is the dynamic voltage correlation. That means the current is simulated or calculated rather than the measured. So there's no sense resistor needed. The benefit of this device is it has very low power consumption. It only has 27 microamps at active mode. Also, this device is only measuring the voltage, so it's very flexible when you put this device on your system board. It doesn't need to be closer to the battery. If you want to measure the current, you have to put the gauge closer to the battery. But 621 is the most flexible device that you can put anywhere on your system board, that as long as you be monitoring the voltage of the cell. On the pack side, we also have a easy-use low-end gauge, 27/11. So this one we already RTM'd, which means you can order online. This is the counterpart of 441. Mainly is targeting for customers who want to handle high current, but also want to put the gauge on the pack side to get more benefit out of the gauge. The last column on the right side will be the ID chip, as well as some of the authentication. So this is all inside the battery pack from 2022 all the way to 26100. 2022 so far is the most popular ID chip that you can store a unique key into this device so that your host can authenticate the pack, make sure you are charging the right pack. For example, right now a lot of customers mixing 4.2 volt cell versus 4.35 volt cell, so the host need to know which voltage of the cell is allowed to charge to. 26100 is the SHA-1 authentication, which is the more advanced authentication protocol. So we have that also in our portfolio. So overall, this is our gauging portfolio that allow you to pick which one you want to use based on your size requirement, your current requirement, as well as how much accuracy you want to achieve. So with that, I will hand over to Keita for the next slide.
All right, and thank you, Miguel and Ming, for that charging and gauging portfolio overview. In addition to the battery management parts that we have on the fuel tank, we also wanted to cover the complementary parts in our power organization. The TPS63001 buck boost regulator that is in the Fuel Tank BoosterPack is actually part of a bigger line of products that offer huge value in their efficiency over a wide BN rate. Since the release of the TPS63K family, TI has introduced a number of new buck boosts with smaller footprints and features such as the programmable soft start. With the 63001 having 96% efficiency, the latest product in this line also features this integrated soft start and a voltage ripple of less than 30 millivolts. For more information on these parts and how they can add value to your designs, please contact Ann Liu at ann.liu@ti.com. So, as you can see from this presentation, TI Battery Management offers lots of resources to get you to production faster with a smarter, safer battery, longer runtime, and with the latest technologies. So where do we go from here? Well, definitely go ahead and purchase the Fuel Tank BoosterPack on our e-store at e-store.ti.com. At $26.99, it's definitely a bargain. You can check out some of our other EVMs for parts as well, and it's a great resource to begin looking at TI parts. To learn about TI's battery management, the portfolio, and how it can help you, check out ti.com/battery for more information. You can get samples, app notes, reference designs, and more. Now, if you want to win one of those 5 booster packs, ensure that you follow the instructions on the registration page, including sending those emails to tech-support@element-14.com of the people you invited to attend. We will not use the emails beyond identifying who referred the most people. Thank you again for listening to this presentation. And with that, we would like to open it up for questions. I know there are several questions that came up during the webinar. Christian, could you bring some of those up?
Yes, certainly. Thank you, Keita. The first question is from Jason Rubadu, and he asks, how easy is it to use other cells instead of this one? Would anyone care to take that question, please?
Well, this is the main. I want to know when you're talking about different cell. First of all, from a gauge perspective, each gauge, for example, 510, this particular gauge, we do have a couple of parameters that is specified for certain for the cell you're going to use. For example, the design capacity, your charge voltage, your terminate voltage, those type of parameters need to be modified if you use a different cell.
From a charger point of view, then the particular device used on the fuel tank, it's for charges for 4.2 volts is the termination voltage. So anything that can support 4.2 volts, it could be in theory charged. The maximum charge current then is 800 milliamps.
Okay, thank you for that. We have a question from Jonathan James. What is the expected lifetime of the EEPROM? And he puts in brackets, how frequently is it written to?
Is this talking about the EEPROM in the gauge or the charger?
He doesn't specify. Perhaps if you could take it in turn to talk about.
Okay, I'll go ahead and talk about the 510 gauge. The field gauge 27510, we use flash. It's a flash-based. And the flash-based gauge, normally we have two sections. One is called instruction flash. That is the memory store all the algorithm, the firmware. It won't rewrite during the use of this gauge. Once it's programmed in TI factory, it's done. The other section of the data flash is a data flash, which you store all the configuration parameters. Then there's a section called resistance, because we're impedance tracking. So we learn the impedance, we store in certain section of the data flash, and that flash can read and write for I think it's a 20K times. So that means you probably have a very long lifetime before you wear out the flash.
On the charger side, we don't have a double EEPROM on this particular device.
Okay, thank you very much. Next question comes from Eduardo Corpeño. He says that he hopes this isn't not very off topic, but he wants to know what happened to Stellaris. Is it discontinued, replaced by Tiva? Why? Kaita, do you care to take that one?
Sure, and I'd like to see if Adrian's on the line. All right, so with regards to the Stellaris and the Tiva C question, I wanted to just briefly go over Tiva C and talk a little bit about how it's kind of replacing Stellaris here at TI. So many of the Stellarisware that you might have heard of, some of those software libraries, they're being transferred to Tiva C because we want to make sure that our products can reach more of our customers. Using the ARM base and using that as the base for the Tiva products, such as Tiva C, Tiva L, really enables our customers to bring code from other designs and ramp up quickly, right? So we want to make sure that your designs are able to be designed faster, and part of that is that transition from Stellaris to Tiva C. So hopefully that answers your question.
Okay, thank you very much. We have a question from Don Bertke. Is there any information about how much of the voltage source is able to be stored on the battery, i.e. source-to-storage efficiency?
Okay, so for this, I think our gauge is kind of different than the traditional, voltage-based, right? So we only have you can think about this as a equation. So we have input of current, temperature, impedance, and this equation going to calculate what is the remaining capacity. So the voltage, we do have a open circuit voltage that is depends on the chemistry you're using on this particular cell. But other than that, we don't store a lot of voltage points. I don't know if I answer your question, but we're not traditional voltage-based gauge. So there's a no lookup table.
Okay, thanks. We have a question from Bing Huang. Does impedance tracking only work with a battery from day one? Can one switch to another battery already in use?
Well, for 510, you have to use the same type of battery. You can use a new battery to start with, and once the battery is aged, you can switch to a different one. So we have a arbitration algorithm built into this device that can detect the impedance of the battery you inserted. Then from there, they can determine if this is a new battery or it's a used one or it's a previous one. So there's a lot, judgment going on before the impedance get learned. So, but it has to be the same capacity, same chemistry, but different age for 510. We do have a different gauge. For example, it's not on this list, but it's in our website. It's called 27501. In that gauge, you do store two type of profile, allow you to use totally two different type of battery, different capacity, different chemistry. It's all can be used. But for 510, you can only use the same type, same capacity, but different age.
And the next question comes from Brad Walsh. He says, how do these modules measure battery temperature? Does the cell have an inbuilt thermal resistor, or is it estimated using internal impedance measurement?
I guess this is really depends on the board design. I don't have a visibility on that.
Don't worry. For those who don't have their questions answered during this session, we are taking down all your questions, and we will be posting a blog with all the questions and the answers later on, along with the video. So the next question is that Andrew Spencer is asking, I'm seeing that lithium-ion battery manufacturers only sell batteries via a pack assembler that adds a safety circuit to the pack. Does this safety circuit have any interaction issues with the TI charging chips?
So when you select the battery pack and you select the charger, you need to keep an eye on what is the threshold for recovery voltage. So if the battery gets completely discharged, so there's typically two types of protection, under voltage, over voltage. In some cases, they also add overcurrent. If you look at under voltage, typically the protector will have, and the battery manufacturer will give you this information, you have the entry and you have the exit threshold. So let's say you have a charger that your default value is, call it 3.5, and your exit threshold is 2.9 or 3 volts. That only gives 500 millivolts of delta, which it's not enough in some cases to close that protector. So the answer is potentially yes, and that is an area that when you're looking at the charger, you want to look at the default output voltage, and you want to look at the battery pack specs to make sure that you don't have a problem. From the over voltage side, typically our chargers with a 1% or better accuracy, in most cases what we find most batteries, the over voltage is actually higher than our accuracy. So from that point of view, typically we're pretty safe in that area.
Okay, we have a question from Harry Sampson. Can the same gauge be reprogrammed for different battery chemistries?
Yes, of course. The benefit of flash-based gauge is its flexibility. If you have a different battery inserted that your host already know which one, that host can rewrite the configuration file in the gauge to compatible with the battery you're going to use.
Okay, thank you. We have a question from Carlos Urquita. He's asking, if the battery short circuits, will the IC protect itself or burn out?
All right, so go ahead.
So from a charger point of view, and I guess Ming, you can also talk about it from the gauge point of view. When the battery short circuits, we have short circuit protection on our charger IC. So we will try to charge at a very low current, and we will know that you have a bad battery, so it won't damage the charger itself.
Yeah, I mean from the gauge perspective, there's no damage to the gauge because once it's overcurrent, the protection kicking, you really don't see any voltage on your battery cell, so the gauge is okay.
Okay, thank you very much. I think that we've come to the end of the question and answer session. Oh, pardon me. We have one more from Kevin Stewart. What's the best way to match lithium-ion batteries to the charging and gauge circuitry?
Okay, for the gauge, it's very easy. Once we know what battery you're using, we can run some discharge to get the discharge curve. From there, we can determine what is the chemistry profile. We have a database already have like hundreds, thousands of profiles stored, so we can compare. Then we know which chemical ID you should use. Then we can put that into your configuration file.
Right. From the charger, the most important thing is knowing the specs of the battery. So what is the charge voltage that you want to, and the charge current that the battery manufacturer will allow you to. From there, you can start and select the charger that fits those requirements. And then after that, really, it's more about system design as far as what features you want to enable. Do you want to start up with dead battery? Do you care about dead battery startup? That kind of thing.
Okay, thank you very much. If there are no further questions, I'd like to thank the team at Texas Instruments for this very interesting webinar. My colleague Vandana Lokeshwar. We will be doing more webinars with Texas Instruments in the near future. Oh, we have one more question. Just one second. How many? One final question. How many battery cells will these chargers support?
How many battery cells? So the 24210 on the fuel tank is a single cell charger. However, on the slides that we showed about different chargers, we can go from single cell all the way to about 5 cells in series from a lithium-ion point of view. So it really depends on which charger. The fuel tank right now is designed for a single cell system.
Okay, thank you very much. And I'd like to finish off with a compliment from one of the attendees, Don Berthke, who is one of our long-standing members in the community. He would like to say, good webinar, very informative. With that, I'd like to thank the entire team at Texas Instruments, Vandana, and stay tuned for more webinars from Texas Instruments and Element 14. And with that, I say goodbye.